So let's do a quick review of what we know about atoms. This is a carbon atom. How do I know that? Well, if I count up the protons, there are 1, 2, 3, 4, 5, 6 protons. This is an artist's rendition. It's not perfect, but you get the idea. So I can say that this has 6 protons in it. They're the positive ones, as you remember, and that's what defines an element, how many protons it has. But it also has 6 neutrons. 1, 2, 3, 4, 5, 6. And I know that because its mass is 12. So its atomic mass is 12. Literally, that means that there are 12 little things in here. So each one of those is assigned a mass unit of 1, and everything is built on these things. So I've got my electrons on the outside, and they match my protons in something that's not an ion. So this would be as carbon is seen in the periodic table. Just write carbon here so no one gets confused. And I can see that carbon's symbol on the periodic table, there's a C with a 6 and a 12 down below. This is its atomic number. That means how many protons there are, and that's what defines it as an element. This is its atomic mass, and most of them have a unique atomic mass. It's actually a bit of an average because once in a while they have 1 or 2 fewer or greater neutrons. So once in a while there's a decimal there. But for the most part, especially in the first 20, you can pretty much count how many protons and neutrons there are by looking at this atomic mass. So the 12 is the atomic mass. Now that's how we're used to looking at that number. When we start talking about moles, we're talking about how many actual atoms there are in 12 grams of carbon. So not that we're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 subatomic particles, but that we're taking that and sort of increasing it and using 12 grams. So if each of the little particles is worth the same amount, then I should be able to weigh out the atomic mass in grams and have the same number of particles of carbon for 12 grams as I do for oxygen for 16 grams. So it's basically multiplying the base unit by a mole, and that gets me to 12 grams. So this guy is going to have the same number of particles in 12 grams as hydrogen would have in 1 gram, because hydrogen is simply a proton. Guess I should have made that red. Hydrogen is a proton. It's got an electron around it, but electrons don't count for anything for mass. So that's pretty much hydrogen right there. So if I had the same number of these guys as I had of these guys, and I use 12 grams of this and 1 gram of this, then that should equal out. If I had uranium, which is 238 for its mass, that would count 238 subatomic particles, but if I use 238 grams, I should have the same number of atoms as I do of these guys. Hopefully that makes sense. What we're trying to do is recognize that the atomic mass is also equal to what we call the molar mass. It's just that the atomic mass uses mass units. They're just mass units. They're just basically saying, yeah, I'm going to count these things. And the molar mass is grams per mole. So it's actually counted in grams. That's what we're going to be working with here, is recognizing that if I have a sample of carbon and it's 12 grams, then I have the same number of carbon atoms as I would if I had 1 gram of hydrogen, because hydrogen is a unit of 1, and carbon is a unit of 12. Carbon gets used a lot because it's really stable and it's easy to measure. So that's actually what moles are based off of, is if this base unit has 12 and I get 12 grams of it, then that number of particles is going to be this universal number of particles that I can use for any element if I have the same number of grams as the atomic number.